using them all the time. So 100 years ago, people were doing research, and I'm talking about scientists, right? We're doing research, and they were putting together papers, research papers, to present to their colleagues and say, hey, look at this, I've discovered this, right? And within this paper, this 400-page paper, right, of research, they might have to show some mathematical stuff in that paper where they were using these logarithms. And it's kind of tedious. This looks, I don't know, it's a little cluttered, right? That just kind of looks a little cluttered. Yeah. I mean, we can write it down, but no one here has ever had to use a typewriter, right? You have, I mean, like a legit, real old school, yeah? Yeah, so the way everyone's like getting nostalgic, right? Like my niece, she has what are they called? Those Sony Walkman CD players. You know what I'm talking about? It's like a portable CD player, right? So they got my brother's one working, and then she called me up. She's like, do you have any CDs? I was like, oh, got a bucket of CDs. So I gave her all my old CDs. So everyone's getting all nostalgic now, right? So typewriters are hard to find nowadays, the old school ones. Anyway, the point is, if you've ever used a typewriter, you type in these physical like levers come up and hit the paper with an ink impression, right? And you sit there and type. Well, if you're typing a paper, right? Imagine back, I don't know, 50, 60, 80 years ago, they're typing papers, and they have to do the logarithm, and maybe the logarithm appears hundreds of times within their paper. Subscripting is hard to do on a typewriter, right? This subscript, because what you have to do when you're typing is you type and you stop, and you turn your little drum thing, and then you would type, like let's say you were trying to type this, right? You would hit LOG, turn your thing, E, turn it back, and then continue typing, right? Imagine having to do that hundreds of times. It'd be a real pain in the ass, wouldn't it? So what happened was people agreed, let's not use that notation because the subscripting kind of makes things hard. So what we did is we changed the notation to something that's easy to type without having to ever stop. The bad part about it is that people then lose sight of the fact that it's just a logarithm, right? So the notation that we use is not this. We don't use that. We actually do this. All right? This is an L, and that's an N, and this is X. And what it stands for is logarithm natural. Now, in French, right, the way French say things, they kind of do things backwards. So instead of the natural logarithm, okay, because this was called the natural exponential function, this right here is the natural log function. It's the logarithm that naturally appears, and we're not quite sure why it works, but it does. So this is ln x, not in. A lot of people think it's in, it's ln x. But all this means is that, okay? Do not forget that. This means this, all right? And then this one, we said, okay, instead of doing that, just type this, or just write this. And that one really gets people because we're just eliminating the 10, and we're using LOG. Normally, you're supposed to put a number down here. If you don't put a number, it's understood that it's 10. See the difference between these two notations? On your calculators, you should have a key for natural log x. It should be there. Actually, remember when we were doing e to the x in class? I think the key that was below that was natural log x, and a lot of you had to hit the shift on your calculator to get to the e to the x. Now you don't have to do shift anymore if you want to use this function. All right? Do any of you have the log key, LOG? Yes? So you got them both on your calculators. All right? So let's just see if we can use the key real quick on your calculator. Let's type something, or let me write something first. So if I write this on the board, and let me do this to remind you. If I wrote this right here, can somebody tell me what that means, what that's asking you to do? Or somehow translate this? This goes to the last class. 2 to what power is 8, right? That's what that's asking. 2 to what power is 8? Can you all tell me 2 to what power is 8? 2 raised to what power is 8? What is it? 3, right? Right? This is true. 2 raised to the third power is 8. So 2 raised to the third power is equal to 8. 2 times 2 times 2 is 8. So you all agree with that? Okay. Now I'm going to ask you this. What's the natural log of 3? Okay, so let's go back here. What is it? Rewrite it from this back to this. What is this really asking? Or what does this really mean? Log what base? What base? E 3, right? That's what that's saying. So this is saying e to what power is 3, right? You know what? Hold on, sorry. I want to change this to 8. Sorry, change that to 8. I apologize. I want it to match this. So this notation right here, log base 2 of 8, means 2 to what power is 8, and everyone here said 3. 2 to what power is 8? If I write this, natural log of 8, then I really mean e to what power is 8. Can anyone off top of their head tell me what power you raise e to get 8? No, right? You're not going to be able to. No one here is going to be able to tell me what power you raise e to get 8. But your calculator will, all right? So type in natural log of 8 on your calculator and tell me what you get. 2.07, something like that? Okay. Let's see. Let's check, is that answer correct? Let's see if that answer makes sense. You all right?
Oh, yeah, fine.
Okay, all right. So let's check this. Is this right? Is this right? So let's try the loop. Is that right? So if we take e and raise it to the 2.07, will we get 8? Do that on your calculator now. And you should get something really close to 8. I don't think it's going to be exactly 8 because we rounded. 7.9 something, all right? Questions? I just want you to see what this key is doing on your calculator. If you type into your calculator natural log of 8, your answer is what power you have to raise e to get that number.
Can we do one more?
Yeah. Yeah, let's do another one. So if I say what's natural log of 10, then what this really means is e to what power is 10. Okay? This really means this. Now, nobody here knows what power you raise e to get 10, but your calculator, type it in, and what do you get as an answer? What do you get?
2.30.
2.30? Okay, 2.3 something, all right? And then that's it, that's our answer. We could check it by doing this. This right here is a check. This is us just checking to see that it works. All right, if you take e and raise it to the 2.30, do you get something close to 10? 9 point something. So so this key is like a shortcut that allows us to not have to do the calculation, right? Y'all okay? Yeah, I'm going to leave it there. I have a new question for you though, all right? How about this? What's log base 2 of 5? Okay, somebody tell me in words what that's asking. 2 to what power? It's 5. Who's saying that? Who said that? Okay, I hear you, but I didn't see your mouth moving, so I'm like, I hear the voice. I don't see where it's coming from. Okay, so you said it's what? 2 to what power is 5? Anybody know what power you raise 2 to get 5? No. So does your calculator know? This key, the natural log key on your calculator, only works if your base is what? E, right? Your base has to be E for you to be able to use your calculator, right? You see that? So it seems like, well, wait a minute. That's great that we have a key for base E, but what about base 2? We don't have a key for base 2. Or what about base 7? Or what about base, whatever, right? So it seems like, okay, great, we have this, but it limits us, doesn't it? Not so fast, all right? So this is, we don't know, okay? We don't know. But then we have this beautiful formula that you don't need to worry about where it comes from, all right? Here it is. We have this very important, what's called the change of base formula. And And this is really important to us. Here's what it says. If you're ever trying to take a logarithm, and it doesn't matter what the base is, and you've got some number there, right? Like I got right here, right? I've got log base a, right? So for us, the a is 2, and the x is 5, right? It says if you ever have that, all this is equal to is the natural log of x divided by the natural log of a. And again, just take it, believe it, and we move forward, all right? Which means the big takeaway of this is it doesn't matter what log anybody gives me. It can be any base. Doesn't matter. All I need to be able to calculate it is the natural log. And that's why your calculators only need to have one key on there. It only needs the natural log key because it takes care of all logs. So let's go back over here and do this problem. So this would be the natural log of 5 divided by the natural log of 2. Now, be careful. I'm not telling you to do this. I'm not telling you to put 5 divided by 2 into a natural log. That's not what I'm saying. It's 2 different logs. You have to figure out what the natural log of 5 is, and then divide that by the natural log of 2. You can type it all in at one time, though. You can do natural log of 5, close the parenthesis, natural log 5, close the parenthesis, divided by natural log 2. Who's got the answer? What is it? 2.3. 2.3. And we can check this answer again. We can take our base 2, raise it to the 2.3, and we should get something close to 5. You should get something close to 5. Does anybody have any questions on their calculators or anything? Yes? Yeah. The natural log? So is it on? Okay. It's that key right there. See that? Okay, so hit it and then put 5, close parenthesis above the 9, and then divide. So hit the division. And then now natural log again, and then 2, and close the parenthesis. So you just type this line in right here. You see that? You just type that in. And now hit enter, and you should get 2.3. Got it? Okay, we're going to do another example.
I did it backwards.
You did okay, so make sure you do it the right way. So when you see this formula, you see the a is on the bottom here in this form. It's on the bottom. That's where the natural log. That's where the a goes here. It's the natural log that's on the bottom, and then the x goes up the top. All right, let's try another one. All right, so I'm going to give you another logarithm. See if you can use your calculator to figure this out. What is log? Let's go base 7 of 2. So check out what that's asking. 7 raised to what power gives you 2? 7 to what power is 2? 7 to what power is 2? Who knows? I don't know. My calculator is going to tell me, though, because I'm going to do natural log 2 over natural log 7 on my calculator. What do you get? About what? 0.356 is your answer. And again, what this is telling me is that if I take 7 and I raise it to the 0.356, I will get something that's approximately equal to 2. Anyone have questions there? Yes?
So for that one, the ln, that only looks for e and the log.
This?
It only works for 10 and e.
No. When you see natural log of something, right? When you see this, what you have to know is that this is a logarithm where the base of it is e. That's what natural log means. It means the base is e. This could be a 7, that's a 7. I could place 5 here, 5 here. The important thing is that this notation, because of the typewriter, we didn't want to have to do subscripting. This means that you really have a logarithm where your base is e. See, this is why I hate that we ever switched away from it, because students, like right here, can you tell me the base of that log? E, right? Right, well, right, it's right there in front of you, right? But over here, you lose sight of that this is a log with a base. So it's as helpful as it was. You all right?
Oh, yes, sir.
Okay. As helpful as that notation was for people using typewriters, it's actually caused more confusion than helped anything. Okay. We're getting somewhere here. We're starting to get to, we're almost to the point that all of this work has been for, which is to go back to that problem with us putting money in the bank and trying to figure out if we wanted to like double our money, how long it would take for that to happen, right? That was a problem I put on the board a long time ago. So we're almost there. I have to develop just a few more things and then we'll be ready, okay? So properties of logs. All right. So here's the first property of a log. If you give me any log with any base and you try and plug a 1 in there, what's the answer? Now you can't use your calculator here. You just have to think through this. What is this question asking? A to what power gives you 1? 0. Good. A to the 0 is 1, right? Any number to the 0 is 1. So the answer is 0. This is a property. We call it a property because this works for all logarithms. Let me give you some examples of this property. If I write what's log base 5 of 0, what would you say? I'm sorry, you wouldn't say anything. What's log base 5 of 1? You would say 0, right? I'm using this property. Anytime you plug 1 into a log, the base doesn't matter anymore. Your answer is always going to be 0. Here's another example, and I'm going to do this one in blue because it's important. What is the natural log of 1? Now you could use your calculator, but think about what this is saying. E to what power is 1? Well, A to what power is 1? For any A, it's going to be 0, right? So the answer to this should be what? 0. Okay, I'm going to box this one because this is a property I'm actually going to need. All right, next property. What's log base A of A? So this question is saying A to what power gives me A?
0.
A to the 0 is 1. What power do I raise A to get A? 1. Right? 1. Do y'all agree A to the first power is A? So as a specific example, if I asked you what's log base 5 of 5, what would be your answer? 1. If I said what's log base 7 of 7? 1. What's log base 4 of 4? 1. What's log base 10 of 10, right? Let's do this one. What is the base here? What's the base here? E, right? So what would I have to put here to make this property, what would I have to plug in? What number, if I do log base E, what number do I have to put here to get 1 as an answer? I have to do this, right? Log base E of E would be 1, wouldn't it? But how would you write this? Because typewriters, we wouldn't write that. What would we write? Natural log, which takes care of this and this, right? But you still have to put what here? E. Natural log of E should be 1. It's weird notation. This one is really important. This one right here, okay? The natural log of E is 1. The natural log of E is 1. Third property. There's 2 more properties, okay? Log base A of A to the N. The difference between these 2 formulas is that this was saying A to what power is A, and then this one is saying A to what power is A to the nth power. A to what power is A to the nth power? What do you think? N. N. Let me give you a specific example. If I do log base 5 of 5 to the 3rd power, because this base and this base are the same, my answer is just going to be 3. Y'all see the formula there? Log base a of a to the n, the answer is n. Over here, specific example, or not specific, for this, if I write e, natural log of e to the n, this would give me n. Box that one up. So if I just have natural log of e, this goes away and it turns into a 1. But if I have natural log of e to a power, then basically the power is all that's left. And the fourth and final property, and probably for people who would go on and take more math, the most important one, is this. Log base a, and now pay attention here, of, how do I want to do this? Of m to the n equals n log base a of m. All right, this property is weird. It's out of nowhere. It's like, what the hell are you doing? Like, where did this come from? All right? And I understand it looks terrible, but let's see what the property is saying. Do you all see the difference between these two properties? They both have the same base, right? But do you see the next statement? This is not the same. These match here, right? But these are not matching anymore, right? These two don't match. So when they don't match, this property says, can anyone look at it and tell me that, like, what happened from the left side to the right side? What changed? Whatever the power is, it came out in front. Do y'all see that? This power right here, n, we basically took it and dumped it off in the front, and that becomes multiplication. That is a property of logs. I'll put it up here as well. That is a property of logs that you need to know. You'll see me use these. I'm about to use these in a minute, all right? So let's do that. Let's just leave that there. I like it just like this. This property just like this. Star 3, it gets 3 stars. All right, are you ready? Let me say this again before I move on. This says, for any logarithm, it doesn't matter what it is, if you have something to a power, the power can come out front. Say it again. If you have any logarithm of anything to a power, the power can drop out front. All right? All right, we're ready to go. I don't want to do the word problem yet. I don't want to do it yet. How am I doing on time? Yeah. Yeah, we're gonna do some work before we actually get to the word problem. All right, you got all those properties down? Let's use them. I would like for us to now solve these equations. So all of a sudden, we've been talking about logs and logarithmic functions, and now I'm going to ask you to solve some equations. First equation. Solve that equation. Solve it for x. Now, we've done this problem already. Can everyone tell me what the answer is? It's 3, right? But let's act like we didn't know that, all right? We know the answer should be 3, right? Let's see, how would we solve this? So we're trying to solve for x. Do you see that x is up in an exponent? Okay, I need some method, some technique that is going to pull that exponent down, right? Something that allows me to take that power and bring it out, right? That power and bring it out, right? That's a property of logs, isn't it? So what I'm going to do right now is do you see any logs right here? You don't, do you? But I know that if there was a log in front of this, that power could come out, couldn't it? If there was a log here. There's not. So I'm going to introduce a log. It's kind of like when you multiply both sides of an equation by something. It's kind of the same idea. I'm going to do the log on both sides. And what log should I use? Let's see. Let me think about it. How about the natural log? Because we have a key on our calculator for natural log. I'm going to do the natural log of 2 to the x on the left. Whatever I do to the left, I do to the right. You with me? What I do to the left, I do to the right. Now, yes? The reason I just did that was that property I just put, the fourth property I just put the stars next to. I have a logarithm, right? Something to a power. That means the power can come out. I can take this power and I can free it from the exponent. I can drop it down in front, and that will become my next line. X times natural log of 2 equals natural log of 8. I almost have x by itself, right? This x is almost by itself. In order to get this x by itself, I need to get rid of this, which means I'm going to divide both sides by natural log of 2. So I divide this side by natural log 2, and I divide this side by natural log 2. It goes away here. I just get x. And then over here, well, can you type that into your calculator, please? You should get 3. Try it. Natural log 8 divided by natural log 2. You should get 3. And that's what we said the answer was, right? Yeah? Let's do another example. 50 raised to what power gives you 20? Well, again, nobody's going to tell me what that is, right? No one's going to be able to tell me what that is. 50 to what power is 20? Well, let's solve for the x. So I need that x to free it, right? Bring it out front. I can't do that until I bring in a log. What log should we bring in? The natural log. So we're going to do the natural log on the left, and we're going to do the natural log on the right. And then drop the x. See, but look, you can't drop the x here, right? Please don't do that. You can't just pull this x out. You have to have a logarithm to do it, right? So that's why we brought the log in on both sides. Now you can drop the x. And then the same step as before, divide both sides by natural log of 50. Make sure you get the order of this right. We're doing the natural log of 20 on your calculator, divided by, and then natural log 50. You should get a decimal that's less than 1 here. 0.76. Does the answer make sense to you? We're saying that x should be 0.76, that number. What's 50 to the first power? What would 50 to the 1 be? 50 to the 1 would be 50, right? Well, I want it to be 20, I want it to be smaller, don't I? So this number can't be bigger than 1, it's got to be smaller than 1. Did everyone get this number? Yeah? Okay. Do you all see that what we have developed, it took us a long time. We had to talk about logarithms and what they mean and all this stuff. But now what we have is a way to solve an equation where our variable is up in the exponent. We've never had that ability before logs. You can't do it without logs. All right? All right, let's just keep turning the screws. We talked about turning the screws before in here? Okay, all right. All right, how about this? 8 raised to the 5x equals 45. Okay, what's different about this problem now than what we've done? Yeah, it's not just x up there, it's 5x, right? All right, no big deal. I'm still going to pull it out front. I'm still going to bring a log in and pull the whole 5x out front. So bring in your log on both sides. Both sides. Now you may drop the 5x in front. Now, how you do the next step is kind of up to you. I'm going to stick to what we've been doing. I'm going to leave the 5x alone for right now. And on the right side, I'm going to do the natural log of 45 over natural log of 8 on the calculator. What do you get when you do natural log of 45 divided by natural log of 8? 1.83? Is that what I heard? Yep. Okay, so look what we still have. 5x equals 1.83. Do I want to know what 5x is? No, I want to know what x is. So what do I still need to do now? Divide both sides by 5. And then we'll have x. So divide this by 5, divide that by 5, and your answer will be x is approximately, what is it?
I got 0.366.
0.366. I think that sounds good. Anyone else get that? No?
Yes.
Yes? Okay. 0.366. You getting the idea here? I have another one for you. This one's going to be tricky. You ready? This always throws people off when they see it. All right. E to the 5x equals 2,150. You're trying to solve for x. Where's the x? Up in the power, right? How do you bring it down?
Log.
You need a log, right? So you need a log. What log are we going to use? Natural log, because we have a key on our calculator for this. So I bring the natural log in front of e to the 5x equals natural log of 2150. So far everything's the same, right? I brought the natural log on both sides. Everything's great? I don't know about great, but everything's the same? Yes? Now can I drop it? Yep, take that 5x, drop it in front. So we have 5x times natural log of e equals natural log of 2150. Here is the step that's different. What's different? Does anyone see it? There was a property. Look at your properties. I put a box on one of them. Yeah. This is 1. This is 1. Because these are inverse functions. See, over here, the natural log is not the inverse of the exponential 8 function, right? They're not inverses. But when you have natural log and e, those are inverses. So these basically kill each other off. And this becomes a 1. And 5x times 1 is just 5x, right? So now you don't actually have to divide by the natural log e. You can just ignore it. Your next line is 5x equals, now do this on your calculator. Natural log of 2150. What do you get there? 7.67? And now finally divide both sides by 5. And you'll have x. 1.53? Okay. X is about 1.53. It's actually really nice when we have e, because anytime we have e and we have our variable up here and we drop it down, well, we bring the natural log in and drop it down, that will always turn into a 1, right?